Now I'm going to introduce our speaker, Richard, and Roger, our Solution Centre Manager for Decommissioning. So Richard, can you tell us a little bit about yourself?
Certainly. Good afternoon, everyone. Richard van der Tuin, Dutchman, work in IJmuiden. I've traveled the world quite a bit, double life. First, my dad was Shell, so I grew up traveling, and I continued doing the same later with Schlumberger for 22 years. So my accent is a little bit scattered, so apologies for that.
Well, I'm sure we'll forgive you. Okay, and can you tell us a little bit about what you're going to talk about today?
Absolutely. Yeah, I'll take the next 20 minutes. Going and stepping through the evolution, development of buoyancy through to support with buoyancy to help us recover jackets. So that's been a study that we have had through multiple cycles now. And the recent cycle was supported with OGTC, and we focus on the North Sea.
Super, thank you very much. So, and Roger, can you just tell us a little bit as why we invited Richard to come and speak today?
This is a project that has been supported by OGTC through the Decommissioning Solution Centre, and removal of substructures is estimated to be around 1.1 billion over the next 10 years. So anything we can do that reduces the cost of that part of the decommissioning programme is something that we are interested in, and this is a project that we've been supporting with Ardent this year.
Excellent, thank you, Roger. And on that note, Richard, it's over to you, and your 20 minutes start now.
Thank you so much. On the clock. So let's start zapping through these slides quickly, make sure we all keep on track. So as I introduced, sponsored by OGTC to help us bring this along, we started this about 3 years ago, so it's been ongoing, and it's multiple phases that we need to run through, and I want to show you the progress we've made so far and the concept of design where we're at. So let's first start by the drivers. The drivers of buoyancy rationale. Why does it even make sense for us? Quickly into OSPAR. OSPAR, 1,450 jackets here. About 550 are jacket-based, I should say. And within that 550, there's about 371 that are older than 20 years old. We just start to narrow it down towards the decommissioning scope. 20 is a good cutoff. It doesn't mean magic, but we need to start somewhere. Then we've got our tight field. There is a few colleagues that can actually recover heavy lifts this size, and that might even be aging as well. So we might have a crew change coming up. There's a few new developments happening. There's a few new vessels coming into the market, but still there's very proportionally few solutions to help us with these extremely heavy structures. So just do a bit of a breakdown through these heavy structures and understand where we're at. I think the important qualifier is the ratio between how many structures are there of that weight and how many vessels are able to lift that. And if we use that as a ratio, on the shallower or the not so heavy up to 1,000 tons, ratios 1 and 4, 1 and 2, 1 and 2, and here it starts to get interesting. One vessel, one heavy lifter by 6 jackets or by 10 jackets. So with that said, the heavier ones are obviously the area where there's relatively few ways to lift and get rid of them. That means there's a big area for us to explore and develop in. So we're limiting us to the weights between the 5 and the 10,000 tons. That's that group. And the depth is about 60 to maybe 200 meters, 100 meters. And the other challenge that is absolutely imminent, if we even go into the development of this world, can we beat the price? Can we beat the current benchmark? And the current benchmark is about 4,700 pounds per ton, if I'm not mistaken, by OG UK. And the drive is to reduce that by 35% in the next few years. So we put ourselves, for the remit of our study, where to put our fence posts to at least beat that number. So one area is that the market is there. Now, are we the company or a player who can play this game? Are we in it? Can we play this? So Ardent is a salvage company by trade. So we are used to remove steel from seabed. This is no different, except here it's called salvage. Oil and gas is called decom. There's different involvement from the operators, obviously, where an insurance company is like, here's the money, take care of it. Operators are involved every step down the line. A little bit about salvage or recovery through buoyancy. This is a project, January 2013, the Costa Concordia ran aground, And Ardent was the main contractor to recover this wreck and spare the environment. So the method we used, just briefly, secured the vessel that it wouldn't slide down the cliff it was on and harm the environment further. Then provide a landing platform. This was a structure of 33,000 tons that was manufactured within a year. So imagine being a jacket, for instance, Miller, 12,000 tons being manufactured in 9 months. Not quite happening, but this is for salvage purpose. It's going to live for a year, not for 30 or 40 years. So you have different criteria. We installed sponsoons, our buoyancy tanks, and slowly lowered it and landed it softly, gently on its supports. Then we installed the sponsoons on the starboard side, and we finally refloated the whole vessel. So you can just imagine thinking about jackets along this analogy is not a wild step of the imagination. So we started off quite a while ago, about 2-3 years ago, when we kicked it off at early models, brainstormed this to death. And in a nutshell, we have reduced it to 3 families. One is the float and tow, float it up, tow it out. The next family is, can we reverse the installation? If you consider a barge, a jacket on top, and the installation was push it over the side. Except we've got gravity working against us, so can we lever it back on? Can we pull these jackets back on board? And the last family would be any other means. This is very common in salvage. The Fluvius Tamar in the British Channel, we just recovered this like this a year ago. And the seawall in South Korea was recovered this way. Very common. So with that said, the first one, the reverse, in general terms, got disqualified. Very high bending moments. This poor 40-year-old jacket, you're going to lift and pull it over the back of a jacket. It's going to have forces it's not built to withstand, and you don't know the integrity to start with. In broad lines, this is what its weakness was. There was a lot more engineering done to it. The last family in broad lines, because it was lifted in a horizontal state, right underneath the barge, it needed to be toppled. That was complicated. Either you just throw it over and you don't know what happens to it from then, or you do it with support and guide, which means a lot of additional engineering just to even get started. So that disqualified, and we focused on float and tow, which also is compared to the Costa Concordia. So I'll step you through a few of the optioneering steps that we had. Because we're lifting and because we're floating, the biggest challenge for us was the stability. Can we do this stable along every step along the line? To keep it stable, it's either the best way to have additional weight from the top. Let me just step back one step to get the concept. If an air mattress, bottom of the pool, and you want it to float up, it either goes like a leaf or it finds a place and shoots up. No control. You want to have control over your jacket, obviously. So you can either, if you have a 10,000 structure, add 8,000 of buoyancy to it, so it will actually push, but not enough, and you have another 2 that you lift it. Not as much as a heavy lift, but you have control. You know what's happening. Or you can reverse it. You're trying to lift 10,000 tons, but you add 11,000 tons of buoyancy to it, and you hold it back with anchors, so at least you have control again. Or the last method is through buoyancy, is not the exact word, is waterplane area. You need to have an area cutting through the surface, which means you have stability. So these are the general terms and families that we continued with buoyancy, and we've evaluated them in a number of ways. This is just a quick explanation display on how we approach this. First, challenged every item on its cost, on its weather window, how sensitive is it to the environment, interfaces, how big is the, call it ballet of vessels and ROVs and scala of arrangements that you need to operate. And finally, we couldn't disqualify the gut feeling. Salvage masters are involved in this process throughout. And you see a project, Richard, I don't know, this looks risky. I'll count for that. This doesn't look right. So we've included that too. And we've actually landed on what we called at the time the B2. That looked a bit like a P-shaped, and that was our winner for the moment. It's a great, let's continue working on this one and continue developing that further. We did do the same with the others, but I'll limit myself in the presentation to the P-shape we went on. So finally, we started to take this P-shape through its motions and say, good, here's our jacket. Let's come and position it. And with the P-shape, we didn't have enough stability. There was too much momentum and too many moments in this process that we lost control. It just was either floating or sinking. In that in-between phase, we were not able to control it. That's why we added another F, a shape to it, so we had more control and more leverage along the way. So this process was animated and simulated over and over to have good stability every step down the line. So we got the shape, we got the form, we got the conditions, and we ended up making the general arrangements drawings. And this was one of the key deliverables to get a cost estimate, and not just one on, it's about $3,000 per ton, really get it. So 80% of our numbers have been quotes from suppliers, and of course the general arrangements is a good frame to start building with. All right, so this is what the design finally looked like, and this will take you through the motions, the steps. We focused on the design, obviously, and here is the operational sequence and scenes. And mind you, there's a few tweaks that we still need to do here. We need to run this through the traps on specially risk assess. So let's see if this will run like this. Guy wire is installed for guidance only. There's no forces pulling or lifting it in. It's all buoyancy. It's one of the many ways we discussed. We're not finalized on guy wires or anchors. It's one way of doing it. I love animations. Even for all its lack of detail, it still gives you a very good picture on how this is intended to work and which processes. And they're not cast in stone at this moment. It's just one of those steps we need to go through. We focus on the design of it. Can we rotate? Now we're focusing on how to use it, apply it. Some of the details on the design. Approximately 9 modules at the bottom end. That ferry happens to be Newcastle IJmuiden. Our office is right opposite its port. These models about 100-meter length, 40 meters tall, and every module, 9 of them, are the same dimensions. Relatively small size. A lot of ports and quays helped us in quoting, and a lot of local suppliers or vendors can help us build. It doesn't have to be South Korea or China to get this built. It's assembled and then it's big. Key deliverables is, can we get them into the key sites or the ports in the UK or Scotland? And for the most part, when we did our simulations with an 8,500 ton jacket that we designed this for, we got to a draft of 4 to 6 meters, and that's well aware. So that's one of the big deliveries and delivery criteria for this design. Can we make this is already met. And these are the clamps that are really considered grillage, if you wish. they are going to be designed specifically to the jacket. You can't have one grillage fits all or one clamping system fits all. So that's project specific. In this case, very large bullhorns at the bottom end. They need to find the right position. There's a clamping device or a holdback device on the top, and there's these hydraulic clamps in the middle, a set of 4 of them. And the benefit of that, now you have the weight grabbing onto different areas on the jacket, not just on the 4 at the top, if you were to heavy lift. So one of the other key deliverables, can we beat the 4700? Can we get the benchmark and beat that? And it's a very big function on how many jackets are done. If you just do it over one jacket, there's no way you're going to get cheaper. But of course, you need a number of projects. So if you develop this tool, you need maybe in the range of 5 jackets. So really looking for clients to either bundle their efforts or for us to find an effort that we can have 5 commitments. But you can see that if you have a few jackets happening, and the further you go out, this is when your maintenance costs and your storage costs start to kick in. So you're kind of optimizing at this level. But it's definitely a step change from where we can be, where we have been. And we've done this 3 models, 3 simulations, 3 different sources, 3 different companies, came to roughly the same numbers. So we're starting to get quite confident with this now. So key deliverable is 3,500 or 3,055. Beat that is met. I think that's another key deliverable on a project. So I think that concludes my slides. I hope this gave a very good impression. And some questions right now or later, Nikki.
Thank you. That should just show your appreciation.
Thank you.
And with 4 minutes to spare, so straight to the top
well
of the
done.
class.
I was all stressed out over the clock.
Okay, so let's move into our Q&A now. So, straight from the front. As ever, if you can wait for the mic if you do have a question, just to make sure we pick it up on the audio. Thank you.
Thanks a lot. By the way, probably you mentioned something like that, but what technology readiness level is that at?
I did not mention that. For me, it's always difficult to define. Maybe, Stuart, I can ask you? 3 or 4. 3 or 4? Yeah, I would have said. Yeah.
Okay, thanks. That was it.
Within the animation, there was the cutting process of the base of the jacket.
Good point.
Have you considered implementing a cutting method into the base of your system instead of having that as a separate?
That's a good point. We have not considered it. In fact, we've kind of taken the cutting out of it. We definitely want to make an impact in the cutting as well. Is there ways of doing it differently? Traditionally, diamond wire, off you go. It's relatively slow, and you have this big device latched onto it. You're quite exposed, so we're not that comfortable. We're trying to find a way that we can either pre-cut and stabilize it with clamps, so at least you have a clamp to release, boom, you're gone. Or very innovative ways of cutting. There is developments with laser happening that might help us by the time we get this ready. And even exploring explosives, which is a swear word in oil and gas at the moment, but in the salvage world we're quite confident with it. And the developments have been phenomenal in the past few years. So definitely looking at seeing if we can make a difference.
Thank you.
Okay, next question.
Hi, I've got 3 questions, so I'll just ask them all at the same time. Going back to the technical readiness level, if you're at 3 or 4 at the moment, what will it take you to get to 7 or 8, which is like the pre-commercial use of it? That's question 1. Question 2, what's the module size? You said there was 9 modules. You didn't say what size they were. Okay. And third question is, assuming you remember them all,
you make it my problem.
What's the smallest jacket size or template size? I.e., could you apply it to a large subsea well template type concept? Thank you.
I'll answer in a jumbled version, jumbled reply. Question 2 is the easiest. 9 modules, 40 by 20 by 8, 8 high. And they all fit in a line of 5, makes it 100, and they got the vertical standings. Same tank configuration, 8 tanks per module, 72 tanks to control with the buoyancy. All right, that was the easiest one. The third one was which type of jackets, which range of jackets could we take? The smallest size. So we have modeled this to the optimum. So we've gone through all the jackets that were there, simplified it to death. So bear with us. We've used the weight as the main qualifier, but we know there's a few more, and especially dimensions is the one. If this is a nice four-legged 8,000-ton jacket, fantastic, clamp it, pick it up. If this is a 8,000-ton jacket that happens to have 8 legs, the weight, the center of gravity is much further out. So you won't be able to clamp and lift it because you won't. So it's very, I just want to be cautious that we don't kind of use this as a qualifier only. There's more to it. But simply said, 8,500-ton design of that, of the jacket to be lifted has a versatility range of about 2,000 tons either way. So up to 10, down to 6. But with the modularity, you can take the modules off. So the 6, for instance, is shallower as well. If you come in with a 100-meter tall vessel by that time, you probably don't have the depth for the 100. So you have to take one module off. Everything changes. It still has a volume capacity to lift 6,000 by this time. So it's versatile, and it's not cast in stone. It's case by case.
Jackets, or would you do subsea templates as well?
Yeah, we're not discriminating. If it's heavy and it sits on the bottom, yeah. And then the first question was the most difficult, and I could have forgotten about it, I see. But I didn't. I should have forgotten about it, because this is how long will it take to get readiness level. And these are the steps. I think it will be a push and a pull mechanism, the push from us to keep pushing forward, and pull from the market. How much energy will we get out of it? How much eagerness? I think it's going to be a money story pretty quick. Where do we get funds? Are there investors, or is there a push from clients that say we'll make rig clubs, or we're just keen on doing this? So I think that's the push and the pull mechanism. Just pure net hard work engineering, 2 years. If you go now, then you need to do the engineering. You need to do some testing in Marin tech centers where you can test it and run with it, make your models, and then go to the next level where you manufacture. Okay,
Thank
sure.
you. Next question here.
Hi, my name is John Spatera. I'm head of decommissioning at Atkins. One key issue that we see a lot of is the question of the quality of data that an operator can give you to remove their jacket. Is there any feel for this removal method as to the accuracy of information you require? Jackets typically have marine growth on them, grout inside, all sorts of different things which can affect the stability of, obviously, of a controlled lift.
Yeah. No, it's a good. So we're coming into the shakedown phase of it now, and we haven't really touched some early analysis just on, for instance, is a member flooded? Is it grouted? So maybe it's not symmetrical anymore, it's out of weight. Typically, if you would consider a lot of extra grout, a lot of extra marine growth, what have you, maybe it's 100, 200 tons, 300 tons. On 8,000, it's not going to make a hell of a difference. By the way, you have so much volume that you can counterbalance this again. So that element was not too scary in the early analysis, so I have to excuse for the uncertainty. The second phase, the second part of your question again, it's about slipping my mind. Marine growth and clamping. So the clamping are hydraulics. So we will go out and make measurements. You have to know the diameters first of all. We're at this moment not too concerned with the marine growth. It needs to be proven. But at this stage, we have fairly rough teeth clamps in mind that will actually cut into the steel. We don't have to treat it with caution. It's not going to be lasting another 30 years. Don't have to be soft pads on it. Tear it up. Yep.
Thank you. Next question.
Hi. First of all, I like the flashy presentation. It was really good, so well done for Arden and OGTC for that. It's also good to see the minimal draft, so increasing the competition in that market. I've seen a lot of jacket platforms going over to Norway, so it's good for UK content, and also there could drive cost reductions in that area, the work breakdown structure as well. My question is around buoyancy. So buoyancy methods have been used for jacket removals in the UKCS before. It was achieved, but there is negative feedback. Is that negative feedback, does it cause a reluctance for people to use you? Has it been a theme in the presentations that you've provided? And how do you overcome that?
Yeah. No, I think there was some negativity around one project that was done with buoyancy. I think it was very well engineered and thought through. I think even some areas maybe over-engineered. They could have, it was effectively a four-legged platform, 4 big cigars were mounted on each leg. Those could be installed with 3.5 meters significant wave height, which is huge. I think it's over-engineered at that point. Just take your time and wait for a nice weather window, but okay. It installed nicely, it picked up nicely. And then it's like, oh, it's still 40 meters deep. Where do we go? And I think that's the part where that tripped the whole process up. That's the part where the money started counting, because now they had this whole thing they had to put somewhere, and the decommissioning still had to start, except it was on a different location. In this case, they picked a location closer to shore, quicker to get to, but the complications were not, it wasn't dealt with at all. It just relocated. So I think that was the biggest black spot on it at the time. Because our conditions, we said, get it to shallow draft. We immediately went to a rotate mechanism. It needs to be shallow. So immediately that first concern, I think, was taken out of the equation. Yeah. One quick addition, not only the ports to offload into, but also the manufacturing. Because we considered these smaller modules, you don't need a massive, monstrous shipyard to build. That was one of the qualifiers. Sorry, one in the back.
Yeah, I thought your presentation was very interesting. Conceptually, it's very like a concept which was around about, 20 years ago, the Marine Shuttle. I don't know if you're familiar with that one. But conceptually very similar, and you might be wise to check out if there's any patent issues, because it was similar, a sort of floating wrap around and bring it up. The company since went bust because it was a solution too soon for its time.
Ahead of their time,
It's a pity your solution doesn't take off topsides as well, although it doesn't look as if it'd be too difficult to modify the floating hull to lift off, because I mean the market is oversupplied as I see it at the moment. I mean my studies indicate that 2 heavy lift vessels should pretty well take care of the North Sea heavy large jacket removal for the foreseeable future. And there's an oversupply, so you can only lift off the jacket, then you'll have the topside removers.
Correct.
Yeah, buy one, get the jacket free sort of offer. So I think it's a pity that you haven't developed the concept that you can adapt the top to remove. And one small last technical point, I think you need to be careful when you turn the jackets horizontal, particularly if you're removing the just under the derogation limit, the 9,500 ton jackets with the heavy piles on the top.
Yes.
I know from checks we've done in the past for rotating to horizontal, some of these vertical members are just too slim and the structure is really on the limit. And certainly my conclusion was too risky. So you need to watch some of these strengths in structures.
Well, thank you. So a lot of feedback and valuable feedback. Thank you very much. So some of that rotation, the concept was really taken from the reverse launch as well. It was built that way, so it was in that position before. So exactly, yeah. So there's a couple of elements indeed to still consider. Yeah, the topside lifting, maybe one day. This really grew out from 2-3 years ago as a salvage company, basically recovering from seabed. That's what we do. So we stick to our trade first. We might expand to it, but that's in the future.
We've got another question here, have we? Good. One here. Oh.
Thank you. Hi there, my name's Robin.
Sure.
I've got a question around the modularity side of the actual the asset. How easy is it for you to add modules to it, maybe in transit, and then also when it actually comes back to port, rather than offloading the jackets to dry ground as such? What's to stop you actually using that platform itself as the location for the dismantling?
That's right. No, so again, the second part of the question was much easier. Yes, possible. It might just be the structure itself. Sail into a dry dock and use that. By the models we're making, we're not going to be in a crazy rush for the utilization. We're planning on a jacket a year. So that's conservative. So that is well possible. To install modules in transit, that's not really what we focused on. We said, let's make the buoyancy device built for this jacket that we're going to pick up. Secondly, we've really, to have it modular, versatile, was a wish. We have kept it always in the background, and it's there. The building, the raw points are there, but we didn't have fancy click and connect buttons or latch-ons. Every time you do this, it gets really expensive. We stayed away. So right now, there's just a lot of extra meat to allow it to be welded and built that way. Being a proper Dutchman, we were building a bicycle before we were building a folding bicycle.
Thank you. And this gentleman here.
Yeah, very interesting. Thank you. Have you considered adapting the concept for a reusable jacket? You know, a new build jacket with a minimum integrated topside that can be installed for, say, 4 or 5 years and then recovered, transported somewhere else and reused?
No, I like it. Again, we stayed away from discrimination. We'll pick up anything, reinstall anything, and the innovative imagination starts running.
And would that make it, if you design the jacket to suit, would that make the costs? Would that reduce the costs? For example, you can assume buoyancy in the legs, etc., in your calculations, and it may make the whole process a bit simpler and cheaper.
Maybe, yeah, possible. Yeah, no, it's nice to see when you have a concept like this, all of a sudden you see the possibilities outside of what you designed it for. This could be helped to install, to deinstall, maybe even topsides, maybe transport items across. It's just a semi-sub that lifts heavy things up.
Well, if you have a small integrated topside with a not normally manned type setup for, say, I don't know, 50 to 80 meters, then you're completely free of the heavy lift buoys, if you know what I mean.
I don't quite understand exactly, but
well, the jacket can incorporate an integrated minimum topside facility. Some jackets are built with integrated topsides,
right?
And then it's one structure.
Yeah, possible. Yeah, I can't answer it. Possible. Yeah.
Okay.
Yeah.
You've got time for another couple of questions. Yeah, gentleman here and gentleman at the front.
Sorry, I'm just about to ask another question. Just taking the concept further, is it possible, using the idea of like a master-slave Lego concept, could you break the ballast into multiple segments, master-slave it, and use it to remove an elongated structure like pipelines, etc.?
I'm loving the feedback because the brains keep spinning and finding new solutions. Lego is the absolutely most heard word in the last 3 years in our office.
Okay.
And to the extent that I have a very big box of Lego that we brought, and I've been playing with Lego in office hours, honestly have. It was great really to get ideas going. Yeah, and yes, can be done. Yeah.
Gentleman here.
Well, I was about to ask, what about the almost 50 concrete legs that are lying in the world, some of them with some 300,000 tons? Do you think you can face something
I think
like
that's
that?
when we get excited. As a salvage company, the bigger, the heavier, yes. I'm not sure if this will fit, but that's exactly the bigger, the heavier, the uglier, and it sits at the seabed, yes.
Okay, thank you.
Okay, have we got any more questions? Oh, got this gentleman here.
Crossfire.
You could have bust yours.
Yeah. Go on, let you get your step count up.
In terms of the potential UK content of this technology, we saw a list of ports. There's a few of them I'm struggling to see the credibility of getting up a 100-metre straight line.
Fair enough.
Drag onto a quayside. I mean, Montrose, and there's not the space. Peterhead, you're probably not going to get that structure in there in the first place. So, is there a plan to partner up with a UK-based contractor or a quayside to develop it to the next stage, or is there a risk of all this going elsewhere around the perimeter of North Sea?
Oppositely, one of the key drivers is to find a way to get to the ports. And I think you're right that there are still some hurdles, but the biggest one, getting in with 15, 20 meters, you need relatively shallow. So that was the first and biggest checkbox. Now the second and third one, is there enough concrete? Is it reinforced? Can it take the load? In fact, is it deep enough? At the moment, I think you're also right, but there's a lot of ambition of the port side, and Stuart visited about 11 of them around the country.
Yeah,
That's a good question, and it's, there's a lot of capacity in the yards, and they'll make room to accept these things. But you're right, Montrose at the moment couldn't accept a 100-metre structure, but they'd knock down some buildings if we were going to bring it in.
Right. Yeah.
Thanks, Stuart. And Roger, do you have a question there, I think? Yeah.
Innes has kind of covered it actually, but it was more around, have you considered the costs on the onshore side of things and any special equipment like SPMTs that might be required to get the jacket on? How are you pulling that onto the quayside?
Yeah. So a lot of the device is a device, and if you need your compressors, it's not part of that tool that we built. We're going to rent those in. So those are very job specific. You need them for 3-4 weeks, return them. So that limits your cost. So that's the equipment side. More equipment if you're offloading. For now, actually SPMTs are, I don't know another way for it, but they're a little bit too sexy for what we need. It just needs to be lifted off by a few inches, get the clamps off the ground and drive them off. I don't need to make fancy turns or curves. So right now we have like Caterpillar tracks in mind. Straightforward, drive off, lift and drive off. Also those can be rented. This is the heavy machinery that construction guys have. Keep it simple. Yep.
Okay, we've got time for one last question. Any takers? John.
You may want to speak to Able to see the way they remove the Brent Delta. Able Seaton, the yard that took the Brent Delta platform.
Okay.
They pulled that in with skid shoes, which might be the simple answer you're looking for.
I can't quite hear you, sorry.
Sorry. Can you hear me now?
Yeah.
So, can you hear me now?
Yeah, also.
It's just for recording.
Oh, sorry. The Brent Delta topsides, which were brought on shore from the Iron Lady barge at Able Seaton Yard, used skid shoes.
Yeah.
That might be the simple option you're looking for to bring the jackets ashore.
Absolutely. Thank you. Thank you. Good.
Okay, so that brings us almost to the end of the session. Roger, you got any sort of closing comments?
No, I'd just like to say thank you to Richard for an excellent presentation and some really good questions as well. Because yeah, thank you. Thank you. And I guess the call from us now is, what's the industry support for moving this on to the next phase? So we've completed phase 1. And I guess one of the questions, I won't ask it now, but is, what support do we now need from the industry to try and move this forward, and what are some of the hurdles going to be? So if anybody is willing to help us with framing up what the next phase looks like, please give us a call. But no, thanks for that. Great to see one of our projects on screen now and feeding back to the wider oil and gas community as well on what we found. So thank you.
Thanks for the chance.
Super. Thank you.